Hello everyone, welcome to the solution of LeetCode problem 1162 named as far from land as possible. Now in this problem, we are given a n by n grid containing only values 0 as 1. Now 0 represents water and 1 represents land. Now we have to find a water cell such that its distance to the nearest land cell is maximized. And we have to return the distance. And if no land or water exists in the grid, we have to return -1. Now, the distance used in this problem is the Manhattan distance. And the formula is the distance between two of the coordinates x0, y0 and x1, y1 is equal to absolute value of x0 minus x1 plus absolute value of y0 minus y1. Now, let's consider the first example. Here, it is a 3 by 3 grid and there are 4, 1. Now, the middle cell, which is 0, the distance of the nearest land cell is maximized from this middle cell because the distance for suppose this 1 and this 0 will be 2. We have to go 1 unit up, 1 unit right. Similarly, for this cell, it will be also 2. For these two cells, it will be also 2 again. So here, we have to return 2. I hope you understood the problem statement. Now let's move on to the algorithm. In this problem, to understand the algorithm, we have taken this example. It is a 6 by 6 grid and we have to find the cell where the distance of this cell and to its nearest land cell is maximized. Now, basically, how can we solve it problem? This is a classic problem of the BFS, which is breadth first search. And we know that in the BFS, the search will be done in a level by level order. But as there are multiple land cells presented here, the search can be started in multiple positions. Now, as the BFS algorithm can start in the multiple positions here, we can call it, this algorithm is multi-source BFS. So now let's understand how basically the BFS works. Initially, in this grid, we have 4 of the cells. 1, 1, 1, 1, which is equal to the land. And the rest of the cells are water. Now, if we start BFS from this one, we can go right, up, left, or down. So what is the valid move here? There are 2 valid moves. In the first move, we can mark it 2. In the second move, we can mark it 2. That means we can go right and down. So here, if we visit these 2 cells, the level is 2. Now for this one, again we can mark it 2, we can mark it 2. It is the second level positions. For this one, we can mark it 2, mark it 2, mark it 2, and mark it 2. For this one, we can mark it 2, 2, 2, and 2. Because from this one, it can go into the 4 of its direction. Now, in the multi-source BFS, we have completed the first iteration. Now we have to go to the third level. That means we have, this is our first level, this is our second level. Now we have to go for the third level. So for the third level, we have to start from all of the 2. Now here for these 2, we can go right and down. So here, this is the third level. This is the third level. From these 2, we can go right. It is already visited. So we can go down. It is the third level. From this to, this is the third level. This is the third level. This is the third level. Now, from this to, it is the third level. From this to, it is the third level. From this to, it is the third level. It is the third level. From this to, it is the third level. It is the third level. From this to, it is the third level. It is the third level. And from this to, it is the third level also. Now here, we have taken the third level, which is this. That means this is the third level of the multi-source BFS. Now, we have to start the iteration again from the visited node 3. So suppose for these 3, we have to visit it. It should be 4. For these 3, its adjacent, it should be 4, and it should be 4, and it should be 4 as well. Now, what is the maximum value we have seen into this grid, which is equal to 4? That means the maximum distance will be 4 minus 1, which will be 3. How so? Because we can go 1 unit down from this 4, 1 unit down and 1 unit right. So there are 3 steps we have to follow. From this 4, we can go 1 unit up and 2 unit right. From this 4, we can go 1 unit up, 2 unit left. From this 4, we can go 2 unit down, 1 unit left. That means in all of the 4 directions, we have to move 3 units, which is the Manhattan distance. And this is how we're going to solve this problem by using the multi-source BFS. I hope you understood the algorithm. Now let's move on to the code. In this problem, the code is pretty simple. At first, we are given a function named max distance, which is a 2-dimensional array. Now we are calculating the dimensions and taking a key of pairs to store the starting point of the BFS. Now we have to scan to the array, and if the current element is equal to 1, that means it is a land cell. So we can start the iteration at this index, which is ij. Now if the key of size is equal to 0 or it is equal to n into m, we have to return -1. Otherwise, we have to initialize a vector distance which is 0, and we have to take a direction array which will store the direction into its 4-directional way. Now we have to run the BFS until the queue is not empty. We have to calculate the size of the queue, and we have to run the loop for each of the size. That means for each of the level. Now we have to store the front element of the queue into a variable current, and we have to remove it. Now we have to check whether we can go to the 4 of the direction of this current element or not. So we have to run a loop which will iterate 4 times. Now the new coordinates will be current elements first element plus direction of I elements first element, and new y will be current element second element plus direction of I of second element. And if the new x is less than 0, or new y is less than 0, or new x greater than or equal to n, or new y greater than or equal to n, or the cell current new xy is equal to 2, we have to simply continue. Otherwise, we have to insert the valid new x and new y into the queue and mark the current cell visited. After completing this, we have to increment the distance. Finally, we have to return distance -1. This is how we're going to solve this problem. I hope you understood the code. Thank you everyone for watching the video. We will get back soon with another LeetCode solution.